Good afternoon, gentle readers. Saturday, November 2, 2024. Here from a desk of Ross Finlayson, sitting in Seattle, Washington. Today's moment in motion. Geometry is motion. Well, in the recording of these videos, in a study of a sort of impromptu, extemporaneous account of a perceived demanded development in the theory of mechanics is how it's been arrived at. Moment in motion is sought to define moment in motion. With regards to the moment, refers to generally an instant in time, and motion refers to something that is moving in space and time. So that also as with regards to moment, it's usually generally considered as a stasis in space. As with regards to the linear and the radial or rotational, those being the concepts with regards to the origin and the original, these matters of perspective and the projective in geometry, and as with regards to space and time, and then with regards to our theory of mechanics and our mathematical theory of mechanics, and then as with regards to the theory as it's developed historically and how it's been arrived at, that what's been seen has been a survey from the perspective of starting in a modern day account where the wave is the milieu of the formulaic account of the dynamics of change in an open system in physics, that it's all waves in a sense, whereas with regards to that not being really the linear and not really being in the rotational, yet reflecting oscillation and restitution and the attenuation and dissipation, these notions of the tendencies and propensities of things, which in the course of these videos has been the reasoning to arrive at why these theories have their perceived excellence in the classical theories, and what parts of them may be considered to be self-contained, classical, and complete. And then as with regards to a sum of histories, sum of potentials, that the potential fields are the real fields in these theories that are field theories and engaged theories, are premier theories of the day, eventually physics as quantum mechanics in the micro scale, and general relativity in a sense in the macro scale. That these things together then get to advising how we can address the laws of motion, the laws of mechanics, the Mertonians after the classics, and then the Galileos and the Newtonian, and then as with regards to how there's these zeroth laws of motion and the reflections on the arguments for and against the very existence of motion, or Zeno's classical expositions of continuity and motion, and as with regards to over time the development of this theory overall. So today what I thought to do is just kind of summarize thusly that then there's been arrived at some various ways to look at what must be supplanting in the foundations these zeroth laws, as with regards to the general sorts of approaches as Einstein in his later theories with regards to the centrally symmetric after the linear, as for differential systems and inertial systems, with regards to the definition of inertia and momentum and one for the other, and as with regards to this an inertial system, and then that momentum is in a sense conserved in the open with regards to pseudomomentum, and these contrasting theories, the vis-motrix, which is Galilean plainly for the plain linear Galilean invariant, and the vis-viva as with regards to that which is the surrounds of the quadratic, that adds the extra term with regards to a higher order term to what would be and what has always been considered to be also associated with momentum and flip and these kinds of things, tipping and toppling and what there are as with regards to this. the radial and this Magnus heft, or is with regards to that the classical does see for the true centrifugal and the notions of the centripetal and the centrifugal counter each other at one way, the other way, each is fictitious, yet has arrived at being so real, the force is so involved, and that this notion of heft is a reasonable complement to the theory, and that makes for space frames, and frame space is simply enough as it can be, what it kind of arrives at to be. These notions that get into then how to make a careful deconstructive account elementarily of the laws of motion and of mechanics to arrive at these parts that end up going missing when there are 90-degree turns or right angles with regards to otherwise the usual clear explanation of the linear as with regards to velocity. 0 meters per second is infinity seconds per meter. What this is seen as to arrive at these ideas of how something can start or stop at all when it eventually results that there's this prime mover or the unmoved mover or the unstoppable force and the immovable objects. With regards to the classical expositions, of course, equal, opposite, or rather motion, rest, and then equal opposite in terms of interactions, then what was also explained or declared was a perceived difference between the kinetic linear and the kinematic rotational, as what with regards to then being able to explain that momentum being conserved in an open system is as if through this sort of the wash, as it were, the rigmarole of the kinematic, because there's to be the perfect inelastic collisions in the rigid bodies, and the deformation is supposed to follow for all these states of matter and such, for the severe abstraction, for the mechanical reduction. So that's a kind of a position statement that helps us summarize that at least these factors are part of the classical exposition and part of mechanics today, according to the fictitious forces or the virtual, often it's put, because what's so relevant to the account of the physical model, or the mathematical model, is the real, and that which is objective in that sense. That's kind of been the result, as after studying otherwise these notions that are the classical and then super classical mechanics of the usual theories of the material, the electrical, the optical, and the radionuclear, that then it's part of a usual physics, this usual mechanics in the 21st century, with as well as regards to what the mathematics has of the day to support such notions vis-a-vis the simplest things, and the classical severe abstraction and mechanical reduction that arrives as was read into the history of the philosophy of science, and the account as of up to about Lagrange as with regards to the mechanics we have today. So what I thought I would do would be to look through some of the works that were consulted over the course of this discussion or monologue, my consideration, my contemplation and deliberation of things with regards to no compromises, and as with regards to an axiomless natural deduction, an axiomless geometry, otherwise such things that philosophy has arrived at are the needful of the requirements and desiderata of a theory overall, and then as with regards to moment and motion, as the last time they're kind of defined to be the same, and thus making a dualism for each other, and that then this is as for geometry is motion and geometry as motion, that the projective and perspective are always present and usually implicit, as with regards to an original sort of analysis where it is so that thusly there's a deconstructive account that results in a structuralist account again as what are otherwise unstated assumptions or implicits. That thusly it could so follow that in such a course there would result a more holistic and thorough understanding of the mechanics. Let's see what we have here today. Early Greek philosophy. So in this Penguin Classics reprint of Barnes's Early Greek Philosophy, what's established is that for the early Greeks is much of what we have that even survives from the time. And so there was a lot of material from the time and before that it did not survive. And so as with regards to then the influences of the greatest thinkers, you kind of arrive at Heraclitus and then Parmenides as establishing dual monism and then a dialectic. And so these were the Eleatics are like the older Greeks, and then from those is like given philosophy at first, and a conscious sort of a contemplation and deliberation, those being part of these complementary duals that help to arrive at what would otherwise would be a lack of thoroughness in this sort of thorough abstraction, the consideration of the thoroughly concrete. So these sorts terms are natural, first of all, and then it helps that they exist in the language, so naturally complementary, thus is the contradistinction and the juxtaposition of them help arrive at how things can be considered instead of arriving what is called here the inductive impasse, which is as a sort of chasm that according to induction can never be crossed, yet somehow according to deduction is. And so this is usually a matter of pointing at Zeno's arguments with regards to the infinitely divisible and motion at all, how there can be this at all. And then with regards to Aristotle's arguments, that there's both atomism and the infinitely divisible, and then Aristotle is largely said to pick one side of this, yet as well as at least so that he entertains both sides of this. Then we have Democritus for atomism, is where Aristotle is basically just kind of the classic side of it, the standard thing. One thing that came up yesterday or last episode with regards to the logic associated with the things is that Chrysippus, at least 400 years before Plotinus, did establish that the classical logic need not include the quasi-modal. So material implication, as after Plotinus and the Stoics, is not included in the classical here. It's considered just a particular false path into what's otherwise for Chrysippus, what's also attributed to Augustus de Morgan with what we have as the rules of logic, the causal, as with regards to the first principles and final causes, and Aristotle and the consideration of the unmoved mover, yet it moves, and such notions of then with regards to here the notions of the big end and little end of the geometric series that are classical is always from the big end, because then it goes to zero as how it can arrive at in this notions of the motion that it starts at all and then arrives at one. This is introduces the notion of an abstract hypercube, and its hypercube distance equals 1. And so when that's got to be the root of the side length, that it sort of works out, and then this hypocube in the straight line segment results. Of course, this results from an axiomless geometry that's got line drawing as a great complement to Euclid's, and to satisfy something like David Hilbert's postulate of continuity that he figured out in his mind geometry had to have, that line drawing is just considered this first continuum. And then our complete Archimedean Eudoxan field, in that Archimedes and Aristotle helped bring to what we have as mathematics today, delta epsilonics and all the great success since then, that there's these kind of higher outside aspects of the fully abstract and the infinite dimensional that collapse back down to our linear and our classical. And then after line drawing for the spiral space-filling curve, which also is kind of a natural continuum that arises in the infinitely dimensional. So at least the mathematics here has one of those as a concept. And the words are the same words, that they have their natural meaning. All right, let's see what we might be able to find from some of these. So the fragments that survive are basically papyri or there's not so much like the clay tablets and stuff like that, or any other way things could be written down. In the ancient times, things that might survive and not be weathered or burned or destroyed or lost, it might include things like obelisks, or sometimes there is made use of metal plates. For example, out of like bronze, they would be inscribed words and works, and as with regards to those surviving over long periods of time. As with regards to the more mythical and mystical periods before 2 or 3 or 4,000 BC, the Iron Age, then the Bronze Age, and this kind of idea as with regards to the usual sphere of Atlantis, being the idea that the Mediterranean and this were all associated this way, as with regards to our phonetic languages after the Phoenicians that arrive today. And that this Hellenistic era then was a time of great civilization, and then as with regards to that today is our classical Western philosophy. And the earlier Greeks then were as those kind of arriving to arise to a state of theoretical abstraction and conscious contemplation, as with regards to a very, of course, logical account of all these kinds of things. So, what I hope to do is find something from Zeno, Zeno of Elea, or Zeno of Megara, or Zeno of the historical figure. What the Pythagoreans say seems to have the same meaning. For some of them said that the motes in the air are soul, others that what moves them is soul. We have said how they can be seen to move continuously even if there is a complete calm. So that might be as with regards to the ethereal. And then also with regards to a theory like a fall gravity, that we have these ultramundane supertachyonic particles in such a theory, which otherwise is a field theory. That's a quote from Aristotle on the soul. And then the Lucretius was another great later Roman physicist of a sort, a theorist, as with regards to the idea of light and the free, if metered, transmission of a signal in the optical, as with regards to the great amount of information that can convey, as with regards to information density and such modern concepts today as the computronium, vis-a-vis the computronium beam, or the delivery of computronium, the most utterly dense storage of information theoretically possible. Plato comments on Socrates. Now Socrates is kind of left out here. He started a school, and it was a school that was open, and then Plato is who's ascribed ideals of the absolutes, and he says Plato on the Phaedo on the soul, 86 BC. And indeed, Socrates, I think that you yourself are aware that we suppose the soul to be something of the sort, our bodies being stretched and contracted by hot and cold and dry and wet and things of this sort. Our souls are the blending and harmony of these things when they are well and appropriately blended with one another. So here you can see that that's the notion that this sort of theory is associated with animism and the theory of human, largely, contemplation and deliberation and existence. That's not so much associated necessarily with the technical here. But it is associated with thinking beings or feeling beings, and then also as well with regards to the model, the fluid model, that in our models of the states of matter, the solids, liquids, and gases, that the fluid model reflects the medium of that, the mesoscale. There's this comment that the Pythagorean is the Pythagorean theorem about the right angles in the circle brought together, so triangles and circles brought together. And here there's that, incites a sort of comment about the n-gonometry and trilateralometry, where it's possible to take an equilateral triangle and unhinge it and evolve it equally about each of its angles, and also draw sine and cosine, the sinusoidal functions. Then also that gets into what are some of the aspects here necessary to consider of the hypercube diagonal, and the sigmoidal as what reaches up to it and gets across it. And then that's really closely related with the concept of convolution, which is the ability to take the product of things from the left and from the right and about their symmetries, and then when they add up together to make it so that the convolutional and the sigmoidal, as for the sinusoidal, are really closely related with regards to a model of motion that's nowhere linear, yet arrives as if from point A to point B. So these are the 5th centuries, and talking about food and drink and the vision and the legs, the generative organs, a part of the universe. Aristotle takes a great position that there's no vacuum, there's no emptiness, there's nothing. No part of the universe is empty. Whence then might anything come? So this is usually as with regards to, you notice it's a question here, not so much a statement. And so he does entertain the notions of the fundamental question of metaphysics, how is there something rather than nothing? And then we fast forward about 200 years to Hegel, who's given that he supplements being with nothing, so that Kant and Hegel have being and nothing, and then Kant has also the sublime, that which is greater than itself, and that Hegel has that that being and nothing are both and either the source. So for like this void axiom theory or universal axiom theory, they're the same. And this is this dually self-inferent consistency, because we can't make any positive stipulation about a theory without being able to derive from it a contradiction. So we can't really make a negative stipulation of the theory, although it would be assumed to kind of like draw that out. That's like what Einstein says. There's only a negative stipulation of relativity, that motion is relative with regards to absolutes and ideals. That's all there is to it. And then he asks, how can such a negative assertion really say anything at all? And then he helps introduce that it's an abstraction, and it's associated with the dimensionality of these things and the concepts. One of the things that was brought up here was the notion of the dimensional and the dimensioned. And so as with regards to the dimensional and dimensionless alternator and resonator, how it can be that such notions as distance and length in the same units have these different augmented or appended or implicit units associated with the one or the other, helping to explain why it's not overcomplicated, why those things can be so considered that way, that it's yet just merely and purely a dimensional analysis of these things. Of strife and love. It reminds me of the sonnet of Shakespeare about sleep. And he says that sleep is the same for everybody. And it's recuperative. Empedocles, at the beginning of his philosophy, says by way of preface that there is an oracle of necessity and ancient decree, that whenever anyone errs and defiles and fear his dear limbs, one of the spirits who have been allotted long-lasting life, he shall wander thrice 10,000 seasons far from it. So this basically sets up divine punishment in the sense of abstract, that there is a law of nature of a sort. Again, not relevant here. It's just kind of caught in passing. And here's these quotes about Zeno of Elea and the millet seeds, and he's like, well, how can you ever say that there's a least quantity? But something like the millet seed was so small that apparently kind of like a grain of sand in the sand reckoner, that it's to be related, the macro scale and the micro scale. And there was the discussion that in this classical era that the macro scale was the cosmos, and the micro scale was man. So that we were each alone, yet at the same time all part of this great infinity of worlds, as it were. in a universe where it's not falsifiable either way, either in both of the Big Bang and steady state hypotheses. Here's Socrates. So sometime later after Parmenides, that Plato is putting words in the mouth of Zeno, Parmenides, and then Socrates, of the Socratic dialogues of a sort, but these being more like Galileo's Salvetti, Sangretti, and that third fellow, when it's developed kind of like in proofs and refutations or Imre Lakatos, the idea of different speakers and then just identifying from their perspectives how they can arrive at a common perspective merely via communication. And then as with regards to something like the cave, that its usual allegory is it's something we're talking about. And so theoretically, it's been escaped in a sense. Zeno himself read to them while Parmenides happened to be out. Zeno, like Parmenides, came from Elea. Virtually nothing is known. According to Antiphon, Pythagorean said that Zeno and Parmenides once came to Athens for the festival of the great Panathenaea, or Pallas Athena, Minerva, Athena. Parmenides was already a very old man, white-haired but of distinguished appearance. He was about 65. Zeno was then nearly 40, tall and pleasant to look at. He was said to have been Parmenides' lover. They were staying with Pythagoras outside the city wall in the Ceramicus. Socrates had gone there, and many others with him, eager to hear Zeno's writings, for this was the first time they had brought them to Athens. Socrates was then very young. Zeno himself read to them, while Parmenides happened to be out. There was only very little of the argument still left to be read, Pythagoras said, when he himself came in, and with him Parmenides and Aristotle, who became one of the 30 tyrants. And so the tyrants is generally associated with the despot, but then it's also associated with the autocratic, and then it's also associated with some other cultural aspects of like the despot, but that's not so relevant here. So they heard just a little of the writings, although Pythagoras himself had actually heard Zeno before. When Socrates had heard him out, he asked Zeno to read again the first hypothesis of the first argument. When it had been read, he said, "Zeno, what do you mean? Are you saying that if more things than one exist, that they must be both similar and dissimilar, which is impossible, for dissimilar things cannot be similar, or similar things dissimilar? Is that it?" "Yes," said Zeno. So this is a quote from Plato and Parmenides, 127a to 127d. So if it is impossible for dissimilar things to be similar and similar things dissimilar, it cannot be that more things than one exist. This is just the usual idea that there's constancy and consistency and diversity and variety, so they both exist in such manner. That is holistic, that is Platonic, whereas, well, it's not necessarily that would be an amorphous whole, that it's actually all the things. So this is again one of these examples of the dialogue that results sorting out then what opinions make classical theories, so then it can be arrived at there are super classical theories. "No," said Zeno, "you have grasped perfectly the overall point of the book." "I see, Parmenides," said Socrates, "that Zeno here wants to be associated with you, not only by his love for you, but also by his treatise. For he has in a way written the same thing as you, although by changing it, he is trying to mislead us into thinking that he is saying something different. You say in your poems that the universe is one, and you produce evidence for the view with great skill. He says that there do not exist more things than one, and he too produces many impressive pieces of evidence. One of you says that one thing exists, the other that there do not exist more things than one, and each of you expresses himself in such a way that you seem not to be saying the same things at all, even though you're saying pretty well the same things, something which seems to be above the heads of the rest of us." "Yes, Socrates," said Zeno, "but you haven't altogether seen the truth about my book. Like a Spartan hound, you are good at chasing and tracking down what I have said. But first, you haven't seen that my book isn't really so very conceited. I did not write with the intention you describe, only to hide the fact from people, as though that were a great achievement. You have mentioned an accidental feature of the book. In truth, it is a sort of defense of Parmenides' argument against those who try to ridicule it on the grounds that if there exists only one thing, then the argument leads to many ridiculous and contradictory conclusions. My book attacks those who say that more things than one exist, giving them as good as they gave it more, and aiming to show that their hypothesis that more things than one exist leads to even more ridiculous results. If you examine it properly, then the hypothesis that only one thing exists. It was with that sort of ambition that I wrote it when I was young. After it was written, someone stole it so that I could not even consider whether it should be brought out into the light or not. So Barnes comments, Zeno's treatise, according to the story, consisted of a series of arguments, each designed to show that the common sense hypothesis that there's more things than one leads to absurdity. So here we just kind of ascribe that there's a universe at all. And so Plato's ideals is that there's an objectivity at all. And today we have all sorts of detachments from that as with regards to fictionalism, nominalism, and as with regards to multiple worlds hypothesis after the stochastic interpretation, since quantum mechanics had been arrived at as being non-deterministic. So Zeno is basically a causal determinist, is what he's saying, and that we all live in one world. This does not disqualify the freedom of individual will of individuals, because that is a matter of information that is free, and that there can be a theory where it's still all one thing, and that we're the properties of our influences, and we have, whether or not there's destiny or fate, that things will be as they will be, that it can still be one world, that at the same time it's not yet written, and that we can still each have our own entire world of thought, because that is yet as all one universe of thinking beings of peace. So then as with regards to that, basically heralding Platonism is a thing in an absolute of ideals, and the ideal of an absolute. And then that would, like, the discourse can then deconstruct that and arrive at all these different things about it. So relevant is a great thing. And Platonism is the theory largely in Western technical philosophy. Bernard de Spagnet's on philosophy and physics. 2,300 years later, we left off at anti-realism in physics in the chapter 7 of the ideas that it arrived at. So what I had found and wanted to get into this a little bit was Ernst Cassirer's book. And so in the early 20th century or more, this is about 100 years before Spagnet. And so Cassirer, I've only started this. He talks here, for example, in section 3 of Theory of the Formation of Concepts, about the negative process of abstraction. That this book called Substance and Function and Einstein's Theory of Relativity by Ernst Cassirer, and I hope to pronounce that correctly, an authorized translation by the Swabies in 1923, has that this has a lot going on with logicism and positivism and the mathematical abstraction to kind of separate us, because Newton's theory was given as like the theory of the world and the system of the world and absolutely deterministic, and so really holding up the ideas of destiny and fate, and then the ideas with regards to whether that was not humanistic or that it was not anthropic, or as with regards to that was rejected, that then as of the time and place it became the notions of scientism after Comte, after Boole, after logicist positivism, logicism in logic and positivism in science, as with regards to this time and place. That in this here, Cassirer is really quite eminent in this, and this book is basically of this same kind of scale and scope as de Spagnet's, but de Spagnet's is bringing back the whole objective thing so that we can have a real one true theory of physics. So de Spagnet, who's like a hedge, has that. Cassirer here is just kind of just really paving the way for logicist positivism as freedom of abstraction and separation of the theory. So with that, in his philosophy, there's to be said that Cassirer is he heralds and predates like Carnap and the Vienna Circle and all that 20 years later, yet as well, it's to be read as has how he develops that it's there's both sides of the ontology as it so represents, and the teleology, that there's a theory is true, and that thusly it's like we attain to it, even though we're strong logicists, positivists, we're still yet strong Platonists, mathematical Platonists, and that can all be one theory. And in fact, there can't not be that without otherwise something not being constant, consistent, complete, or concrete in the infinite diversity and variety of the one universe. The negative process of abstraction. The categorical acts, a system of logical categories. So another thing I've been looking to read is John Stuart Mill's. So Mill also is a great logician, and also he is addressing these sorts of issues. So Mill has got some great logic in the philosophy, and also is associated with the development of logical positivism and in such schools. The mathematical concept and its concrete universality. But from any such conclusion, we are once more safeguarded by consideration of that science in which conceptual definiteness and clarity have reached their highest level. It is at this point indeed that the mathematical concept appears most sharply distinguished from the ontological concept. In the methodological struggle over the limits of mathematics and ontology, which took place in the philosophy of the 18th century, this relation was instantly given happy and significant expression. In his criticism of the logic of the Wolffian school, Lambert pointed out that it was the exclusive merit of mathematical general concepts not to cancel the determinations of the special cases, but in all strictness fully to retain them. When a mathematician makes his formula more general, this means not only that he is to retain all the more special cases, but he also be able to deduce them from the universal formula. Well, that's with some care, and it goes a little bit both ways with regards to the universals and particulars in mathematics, with regards to complementary duals on either side of those. Yet as well, so with regards to the concept, here was with regards to something like Frige's thoughts and ideas, and Heraclitus' concepts. That's still a pretty great statement, though, that mathematical Platonism has that mathematics and science aren't necessarily the same thing. We can have a strong mathematical Platonism, and then we can still have a science, even of it, and then also of it. And that it can be a strong mathematical Platonism as of a universal mathematical universe hypothesis, as that may be the case, as that is so. When a mathematician makes his formula more general, also be able to deduce them from the universal formula. The possibility of deduction is not found in the case of the scholastic concepts, since these, according to the traditional formula, are formed by neglecting the particular, and since the reproduction of the particular moments of the concept seems excluded. Thus, abstraction is very easy for the philosopher, but on the other hand, the determination of the particular from the universal is so much the more difficult. For the process of abstraction, he leaves behind all the particularities in such a way that he cannot recover them, much less reckon the transformations of which they're capable. Well, that just goes without saying, that what goes without saying goes without saying. And so then as regards to complementary duals and the notions of what's elementary and what's central, what's primary and what's fundamental in the theories, that this sort of heno-theory, as Raju introduced in the consideration of the philosophy last time, addresses as it is when the primary concepts are as of the perspective and projective of these. While as yet arriving at one general mathematics usually considered geometry, that geometry is usually considered the numbers and arithmetic in space and form and in the dimensioned quantities. So, well, there's quite a bit more to read from this, but it helps to express and relay that while Cassar is a strong logical positivist, he's like of all these complementary duals as well. So that then he'd always be able to pick that up, and especially to be able to point out that deductive inference is critical and required. And if it doesn't have deductive inference, that if it's just plainly empirical inductive inference, it's not complete and it's not critical. So that way, it helps that otherwise, which is so indisputable about such arguments, the not first false, such things do resolve to a not ultimately untrue as a correct case for induction and inference. That which arrives at logical facts. He talks about algebra, the criticism of the theories of abstraction. So algebra is a great abstraction, and it is to be understood that it is what it is. And so an object of algebra, like a group ring or field, is not necessarily the numbers of arithmetic, because they have a standard and non-standard models. Then we have standard and non-standard algebras to help make them abstract, and thus to be able to treat them according to each of their properties when they're defined is so variously, and their qualities and their quiddity are so as so. So I'm enjoying this Kessler, and there's about as much to read of it as from d'Espagnet. And he mentions something like the attention. I mean, how long do we have that we can give attention to something with regards to maintaining it as central in its deliberation? And that gets into all these ideas of the quantities and derivations and the implicit and such notions. Then he starts talking about the phenomenology and the concept of numbers, and as with regards to associating it with the senses. And here, then that's been established as relating to the physical senses and then the object senses, the mental senses. Those being valid as a form of means that, according to language and interobjective language, can definitely be established. He comments on Mill. We may judge Mill's theory of the fundamental arithmetical principles. We must recognize that it follows with convincing necessity from his general interpretation of the concept. So much the more significant is it that the theory, when carried through, leads to a direct conflict with the fact of scientific arithmetic itself. I'll be looking to study Mill some more. After these moment in motion, of which this will be the conclusion, then there'll be more of the philosophical and various notions of type tomes and such concepts as related to philosophy and physics and logic and mathematics, about continuity, laws of large numbers, at least 3 continuous domains, line reals, field reals, and signal reals, all supported with all this canon. So the bibliography is at once growing rather long, yet at the same time, it's rather brief, yet with many, many references. All of this. The system of arithmetic. Well, I'm going to close the Cassira here, and then for Bernard d'Espagnet, it must be read here. He's talking about the sea and the holes of the Dirac positronic sea as with regards to Einstein's white hole sea, which is kind of the opposite of a black hole, where there's a theory of physics of relativity where the only place that gravity's speed is the same as light's is in the absolute center of a gravitational singularity. And it works out. It's a continuum mechanics. So much appreciation to Cassir and Bernard d'Espagnet there for those. This is a book by Albert Einstein and Leopold Infeld. And so as a population of his book on relativity theory, and I'll imagine I get to this a little bit later, because it's before out of my later years, but what is it talking about? It's things to do with light and electricity and the fields with electrical potential and with regards to heat and electricity and temperature and heat. Temperature and heat are also kind of indistinct yet distinct concepts. The mechanical view, the decline of the mechanical view with regards to mechanical reduction, the philosophical background, the rate of exchange, a roller coaster, something more than kinetic and potential energies, that I was pretty delighted to find this, and I'll be looking through it some more later. Talks about X-rays, the smallest elementary quantum. This statement was believed for a very long time. Now, however, it is no longer believed. Science has formed a new view showing the limitations of the old one. There is scarcely any statement of physics more firmly founded on facts than the one about the complex structure of the atom. This chapter 263 is quanta, but the heading of the section is continuity, discontinuity. And he talks about continuity and discontinuity, and then he doesn't much get into the theory as with regards to atomism and such. If we had to characterize the principal idea of the quantum theory in one sentence, we could say it must be assumed that some physical quantities so far regarded as continuous are composed of elementary quanta, and that is the theory in the theory of continuum mechanics. Aristotle. So we had some great readings from Aristotle. So this is McKeon's translation and revised edition with commentary from McKeon. He wrote the United Nations Universal Declaration of Human Rights. He's got ethics. So the Nicomachean ethics are kind of like the Code of Hammurabi or whatever, common law, and then like reasons why, fairness, egalitarianism, justice, that justice is supposed to be proportional and this kind of thing, which is also a plain Old Testament concept, equal and opposite, as it were. Virtues. Again, this is not technical. The theoretic science, the first philosophy, theology, or wisdom came to be called metaphysics. Physics and the de anima. Here's a fuller treatise of on the soul. On the soul, circular movement is eternal. So there's a physics associated with it because the idea basically is that the same notion of an omnipresent thing is something that's part of the omni. And it has that then its concentrations and dilutions are as well so in their universals in particulars. So then as with regards to that, then it's to be read from an extraction of the idea of the concepts. Some was what are technical with regards to its mechanistic explanation, and others is what so far is associated with the ponderance of the things and the perceived speciality of the presence in the thinking beings and the thinking beings as communicate, or five talking heads philosophers. It's kind of like the Million Monkeys that type Shakespeare, is with the idea that that one of them was Shakespeare, with regards to theories of evolution and such. And the other is as with regards to that there's abstractly five mumbling philosophers, and that they are speaking the theory. It's one of these thought experiments. Vis-a-vis something, there's one called the Chinese Room, which is where someone gets an inscription and they just translate it according to rules, and out goes another ticket. And so whether or not they're actually communicating or inferring about those words or just following rules is as with regards to is like really they don't know. And so it is an act of translation. If it's as so regarded that's not entirely defined, then it's not. So that's great. This is that individual free will involves the responsibility for one's own actions and the ability too. So those are good things. Can the cause of an identical effect be not identical in every instance of the effect but different? It's so, yeah. There is time series data, and it's like when the theory is an inertial system that's a differential system that's a total field theory, no two events are the same except with regards to the intentionality that they are not, with that the extensionality that they are. So that's just same and different. Okay? But here it says with regards to universals. Or is that impossible? So this is part of posterior analytics, and it's to be kept in mind that Aristotle, of course, provides both prior analytics, simple inductive results, classical closed judgments, and posterior analytics, deduction arriving at how contradictions cannot contradict each other, something gives, stroke, judgments. So it's always to be included in the classical logic, the wider dialectic, where otherwise usual sorts of didactic approaches may be considered a half-sided dialectic, and that's fine, and it's great, and it is what it is, and it can be called rulio, and it's regular, and indeed it is. But then with regards to the fuller analytical bridges of the inductive impasse, that somehow we don't all fall into the chasm of can't think. The medieval philosophy. We drew a lot out of this here from reading about mostly Duns Scotus as with regards to the infinity is in. And so that's just something that it's a super classical sort of concept, and so it's associated with him. Kind of like you give to Galois the idea of a mathematical group. It's got individuals, it's got a relation, they each have a unique inverse, there's an identity according to this operation. As an abstraction, yet it's anybody's algebra. It's named for Al-Khwarizmi or Al-Jabr, of the Islamic Enlightenment, 500, 700 years before that there was always the centers of the development of the logic, and it wasn't really so much parallel most of the time, but sometimes it was parallel. And you'll find, for example, developments in the East and West that are parallel. And now they're kind of different, but at the same time, they do arrive at the same fuller things together as they arrive. So Peter the Great, or Peter of Spain, and Albert the Great. Here's St. Augustine. He's talking about the phonetic and words. Man, Augustine, and his interlocutor. Concerning universals, of which we can have knowledge, we do not listen to anyone speaking and making sounds outside ourselves. We listen to truth, which presides over our minds within us. Though, of course, we may be bidden to listen by someone using words. Our real teacher is he who is so listened to, said to dwell in the inner man, namely, deistic references, that the most holy of holies, that is the unchangeable power and eternal wisdom of the superscientific truth, that to which we attain to, or deity. To this wisdom every rational soul gives heed, but to each is given only so much as he is able to receive according to his own good or evil will. Well, see, now Augustine helps to establish like these sorts of dichotomies. It's not technical, so it becomes emergent and relevant in societal after the interpersonal, but it's not so much what's part of this philosophy, it's context. Hugh of St. Victor. Roger Bacon, big fan of Roger Bacon. For authors write many statements, and people believe them through reasoning, which they formulate without experience. See that the experience can be conveyed without having to suffer it, that otherwise some things can only be learned through experience, including learning itself. Aquinas, nor can it be held that both parts of the self move or are moved. So this was part of our discussion on mechanics, is with regards to he picks up Aristotle's works, and as with regards to that being so relevant to the theory of mechanics. So there's not too much more time in this talk. Moment and motion. This is one of the books that made a lot of sense because it's about the collocation. And the collocation is basically the same idea as the hypercube distance, but it's in a square. And so Douglas and DuPont have made this collocation methods for parabolic equations in a single space variable. The idea being that it's a space with multiple things going on with it, but then the single space variable is the same idea as this hypercube distance. So this is basically kind of something to be extracted from it. What would be some of the things that would be so related to the infinitary expressions of the infinite dimensional as what they abstractly are with regards to some of these things that give closed forms and solutions and orderings and equations as with regards to the various cases of the orders with regards to the quadrature that Holder's inequality and Cauchy-Schwarz inequality and the triangle inequality and all these things that are so usual in the linear that the quadrature is part and parcel of the inductive apparatus of the classical development. And so when there's something other than that, the wider rotational, that the quadratic is this second term introduced in the vis-viva for the vis-motrix. The vis-motrix has no quadratic outside term. It's zero. And so it's nilpotent. It's not. It's zero potency, zero area. But the idea that these other things come into play are related to that. Otherwise, without that, then it's a sort of different rule that otherwise you'll find all of mathematics and mathematical physics is a monoculture. And it is for what it is, and it's great. And it can be more fully developed, and indeed it's sort of along these lines. So, and this is about cosmology in 2+1 dimensions of the Zolfrey metric. And so this has when there's either in the classical theory or the theory of relativity when a point is unmoving or a point is moving. Is it a dimensionless body or is it an extended body? So this basically provides an example where it's an extended body. Well, not in the same sense usually as of the Born rule and Pauli principle for Wolfgang Pauli and Max Born, for whom is given the most fundamental reason why quantum mechanics and all the quantum amplitudes add up as they do. That be much before we get things like parastatistics, and it's like these parastatistics after Bose-Einstein and Fermi-Dirac statistics, those being different, do not add up. That these are all these accommodations made to the effects letting out the theory that's otherwise so fundamentally, centrally, elementarily, like so. Heilbronn's sections in mechanics saw several readings here, and each time brought a little bit more of a context. So before this section on medicine and mechanism, the word mechanism is it says here that mechanism is associated with the mechanism of the series of individual changes at molecular level by which a chemical reaction occurs. So these are the explanatory factors. This is the reasoning how something can be so. What's its mechanism? So the mechanics arrive as after a mechanism connecting them. And so in a fall gravity theory, then the mechanism is that there's a fall gravity that bodies occlude each other, and so they naturally fall together without doing any work because there's no perpetual motion machine that would be able to do work all the time and hold us on the planet, unless there's just a universal gradient as the mechanism that allows it to be so. So then this section though is about the atomic model, and is right after this section about mechanics, the mechanical reductions model. So this mentions Thiele and Flersheim and Werner and Van Hoff, Arrhenius, the variation of reaction velocity with temperature. It's part of our statistical ensemble. Arthur Lapworth proved an ionic mechanism. Robinson and Ingold. And then there's section mechanized ether has a section for the ether. So we'll take a look to the ether theory because it basically reflects that there's an idea of a space-time that is its own space. After this section of algebra and etiology, the causes of disease. Ethers in physical theory are distinguished from common matter qualitatively or by quantitative differences, so exaggerated as to constitute a special state or type. Newton used an ether, Newtonian and Cartesian ethers. Here that just reflects on that there's the spiral and the vortex, or the theory of Descartes and Kelvin and such, to help reflect that that is fundamentally going to be primary about these ideas of that's otherwise equal and opposite, is that worlds turn. So this zeroth law is that worlds turn. All right, then I've arrived at that. Well, I guess we'll be getting back into some other stories some other time, some other track of channels of these things. I much enjoyed reading into Moment in Motion and felt that I'd learned a lot. And so I hope that that provides some insight that you can use to refer to the authoritative works since all of antiquity and up through the Enlightenment and our modern rational age, and all quite thoroughly modern. The canon, these are the authorities of this kind of theory. And then that what I'll be getting into is some more about the various aspects of the notions of the foundations. Good luck, gentle readers. I shall so hope that things go well, and that in your deliberation and contemplation of what matters of promise and compromise that there are, and decisions of the fate of the world, that they go well. Moment is motion. Geometry is motion.